As of now, annually, over 1 million children disappear globally, and over 90% are due to endangered runaways/kidnappings. This is what inspired me to create GeoFence, because one missing child is one too many. This is a detailed diagram of my GeoFence design. The Arduino IDE code allows my Arduino GSM 1400 to access my GPS receiver's data and sends it to an IoT cloud via a cellular network using an IoT SIM card. Now, what's so significant about this IoT SIM card? It only costs $1 a month for data, compared to traditional phones that require $15 to $20 a month. The data eventually makes its way to my application using an IoT cloud called ThinkSpeed. The data sent from the GPS goes to ThinkSpeed via a cellular network, and through ThinkSpeed, my app can access the data using an API and display it onto a marker. The app will then evaluate if this marker is inside the designated geofence set by the Guardian, and if it's not, it'll send the data back through ThinkSpeed to my Arduino to tell the OLED and buzzer to go off. My application consists of a geofence screen that allows the Guardian to move a green rectangle, which is the designated area their child should be in. They can move this rectangle either pressing on the screen and holding, or using the green arrows at the bottom of the screen. To make the changes more dramatic while pressing the arrows, you can increase or decrease the numbers in the scale of movement. And to change the size of the rectangle, you can either increase or decrease the number in the scale size box, and you'll immediately see the changes in the size of the rectangle. This is the designer part of my GeoFence screen. If we take a look at the code, we can see the ThinkSpeed API is able to take all the readings from the database and map it on to a point with a marker. To ensure the user's safety and to prevent random people from accessing their location, GeoFence requires two-step verification. The first step being a username and password, and the second step being a face recognition ID. This was made possible using a machine learning model that I created that can recognize my face and differentiate it from others, and imported it into PIC. PIC is a personal image classifier extension that can be imported into MIT App Inventor and executed within that line of code. After it recognizes my face, it allows me into the app. I'm currently at my old elementary school to test out my app's capability. I've currently set my geofence to be in this position exactly, and if we keep walking that way towards the pond, we're going to exit the geofence to see how my app reacts. So I'm not currently at the pond, which is just outside of my geofence zone that I just set over there. I walked all the way from there to this zone, and it's currently indicating that I'm out of the zone as the phone and the GPS is going off like crazy.